Hi again. So today we are going to discuss the tip number 4 in electric circuit analysis problem. So this tip is basically related to the short circuits. Okay, so the benefits of using the short circuits and all the analysis problems which are related to this short circuit problem will be discussed here. So suppose we have a circuit like this one in which we have a source here. It can be the current source or voltage source, but let me consider it a voltage source here, and there is a resistor R1 here. Similarly, the connected resistors here are this one. Okay, these are all the resistors which are connected with my circuit here. Okay, so let me call it R2, R3, R4, R5 and R6. So let's say this is our circuit. So when the circuit is shorted from this end to this end, what will happen? Okay, what will happen is that the circuit will just remain like this one. This circuit will just remain here, and what will be the equivalent circuit now? The equivalent circuit will be now composed of just one resistor, and that resistor would be this R1. Why this? The question is, why is this happening? It is just because that whenever we short circuit two terminal of any circuit, then what happens is when a current will try to come here and it will try to divide through any junction here, it will try to follow the path in which it finds a very low resistance here. Okay, so as the resistance of a short circuit is 0 in ideal cases, and therefore the current will always pass through this short circuit, and therefore the voltage through it will always be 0. Okay, so that would be the case, and here we can find it that when we short circuit any element here, all the current will flow through this one. Okay, so that is the circuit here. Similarly, now there is another scenario here, that if we have a short circuit, okay, let me have a short circuit in another place here. Okay, so let me have a short circuit here. Okay, so what will be the equivalent circuit here? Now let me, this is R3, this is the R4. Okay, so what will be the equivalent circuit now here? So in order to draw the equivalent circuit here, let me use the green color here. So whenever a current will come here, now it will have two paths, this one and this one, and it is not going through the short circuit now, and this short circuit is also away from here, so it will not follow through this one. But whenever this current will reach this junction, what will happen? Now it has two paths here, and the one path here has the lowest resistance possible, which is R equal to 0. So all the current will flow through this one. Okay, so now what will be the circuit here? What will be the equivalent circuit here? The equivalent circuit here will be like this one. This will remain the same, this resistor will remain the same because the same amount of current is flowing here. But as we can see here that after this junction, only all the current will flow this through this one, therefore this circuit will remain this one, R1, R2, and here R3. So it will be the equivalent circuit here. So what is the conclusion here? So the conclusion is, if a short circuit is placed across any parallel element with this one, it will replace that resistor, and therefore that resistor will be neglected and all the current will flow through the short circuit here. So that is the answer here, and that is the tip number 4. Thank you so much, and I will see you soon.